Hello and welcome to this video where I'm going to be assembling the conversion kit I made a few years ago for an R53 xenon headlight system. This will also fit the Morgan headlights, as incidentally they're exactly the same units except they're fitted in inverse sides. So this particular unit is something I developed probably about 3 years ago, and it's basically the PCB housing the LEDs and the components required to allow you to fit this daylight running lights inside the facelift R53 headlights. My first edition that I made was this green board. Over the years I've moved away from this. There's a few things I didn't like. One of those being that I brought the power into the middle of the board because I was trying to keep it as compact as I could. But I did realise that actually, having played around and fitted these to quite a few headlights, there's enough space down here for me to bring the power into the bottom. So this is a bespoke PCB that I've developed, designed, and is only available from me. And these are the components, resistors and LEDs. You can get them from anywhere, but what I try and do, certainly with the LEDs, is I always use Cree LEDs. They give such a good life and they last. This housing here, it's bespoke developed to fit inside this clear section, which you would find inside the R53. So it aligns, and when in the vehicle it will clip into place, and it basically pushes into the housing, so it blacks everything out and you don't then get any light bleeding through from these LEDs. A lot of the conversions that I've seen people do over the years, they'll take an LED or an LED in a single housing and they will just glue that into the back of this. There's nothing inherently wrong with that, except getting the light beam exact. You'll end up getting light beams crisscrossing all over the place. Decided that the right way to do this is a housing. Obviously, if you want to have a go and make your own conversion, that's fine. This kit will be available, and I will put the link below on where you can get these. If there's no link below, assume at this minute in time that we're still setting up the routes to selling this product. So I'm going to go over the assembly, because the plan is that you'll be able to buy this kit in both unassembled and assembled formats. Moving further on, several years ago, as well as the development and design of the green board, I also developed this board, which in its built-up state is here, and that built-up state is actually WS2812 LEDs, and that allows for full RGB and programming per channel. So the plan with this is single white DRLs if you want them, or any colour you want to send to the particular unit. But the other benefit of this unit is you could also have scrolling indicators, which is something I'm working on and hoping to release later on in the year. But for the time being, this video isn't about this particular unit, it's about the one that's going to be available, and that is the single white DRL unit. So this only does white unless you choose to put in a different colour LED, and then it will only do that colour. So what I'm going to do is essentially show you how to go about assembling this kit. So the things you'll need to start with. In this kit, you've got your PCB, let's put that old one over there. You've got 8 resistors and you've got 8 LEDs. The important thing to know about LEDs is they're not bi-directional. They're single direction. You'll have a longer leg and you have a shorter leg. The shorter leg is your cathode. Essentially that's your negative side, and the anode is your positive side of the LED. Also, along with the cathode, on the side of this LED here, there is a flat. This PCB that I've created, I've put artwork around, so when you do come to assemble these, the easiest way to do this is to align the flat and legs, and you basically, through hole technology, push them through, and you continue to do that all the way around and you can solder them up. One of the benefits of this board that I've done is I've kept the flat side all to, on this particular video, this side. It makes it easier for fault finding, so when I flip it over I can now see that all of my short legs for the LEDs are on the left. So before I go ahead and solder, I've got a chance just to make sure that this has been built correctly. But for assembly, what I'll do is I'll put the resistors together first. Generally they'll either come on a strip like this or they'll come loose. We don't need all the legs, so I'm just going to take a good set of snips and remove these resistors. When you come to soldering these resistors in, there's no orientation. Any orientation's fine. It's just down to your OCD on the colour bands of which way you wish to put these into the unit. I like to make sure that I keep them all going one way. When it comes to putting these in, you can buy a tool that bends the legs, but what I tend to do is hold it with a finger and a thumb, and I'll bend the legs over, and that then gives me a perfect bend for the resistor to go in. So go in there. I'm going to start with my tolerance band at the bottom. I will then continue to put all of these in. Now you can start and do the LEDs first, or you can do the resistors first. That is totally up to you. Now the reason I will do the resistors first is if you do the LEDs first, when you come to flip this over to solder it, what you'll see is when you come to do the resistors, sorry, they will fall back out and you'll have them drop and you won't be sitting them as flush, whereas when I flip this over now, I can sit it up against the table and the table will support the resistors and stop them from dropping. Obviously the best way to do this is bend all the resistors before you start the assembly, and then you won't be doing what I'm doing, which is struggling to make sure that everything stays balanced and in. They don't clip, they just push through a hole, so consequently turn it over or you know, fiddle with it as I am, and you're likely to just knock them out. I mean, it's not a huge problem, you just pick them up and put them back in again. So as you can see, we're starting to I'll see if I can put it down. There we go. Let's just bend these two over. So we're then bent over. Again, I'm keeping my colours all going the same way, but if you don't care, just bang them in. Either way around is fine. Okie dokie, so that's all my resistors in. Some of them aren't sitting right, but what I'll do is quickly flip it over. I just rock the PCB on the table. Now I know that they're flat. So your next step is take your soldering iron. I use a short length of 0.9mm solder and we'll tin up to start with. Just this helps with thermal transfer of the solder, and you hold the leg one side and you just go round. There's lots of videos on YouTube for how to solder. Maybe I should watch some. But what I do is just go round. Remember, when it comes to soldering, you don't put the solder on the soldering iron. You put the soldering iron one side of the leg and you touch the solder against the leg, the same as when you're doing wires. If you try and do it by holding your solder onto the iron and then against the wires, what you'll realise is you're actually not going to get full transfer. What you want is the heat to wick the solder into place. So there we go, nice and quickly, all soldered into place, and now I'm ready to put the LEDs in. So what I'll do now is just get these legs cut. All we do for those is you take a set of side cutters, just cut the length of the legs down just above the solder puddle. There we go. Obviously you might want to watch your eyes when you're doing that. You want to keep your table nice and clean as well. Let's get them over there, out of the way. So there we go, that is all of the resistors on the board. So our next step is to get these LEDs in. With your board resistors all soldered into place and trimmed out on the rear, the next step is to take the LEDs and install them. So remembering that you've got the flat, the long leg and the short leg, the positive being your anode, which is your long leg, and your short being the cathode, and that's got the flat on. Follow it round and work your way around the board, just pushing in the LEDs. What you'll notice with these is there's a bit of a step on the legs, and they will sometimes require just a little bit of a push just to go in, but it shouldn't be anything too forceful. If you're having to force them to the point the legs are bending, something's wrong. Again, there are a couple of other telltale signs on how you know you're putting these in correctly. You can see inside the LEDs there's a particular shape, so you could use those if you wanted to, but there's enough features on an LED to make sure that you do put these the right way. If you put them the wrong way, it just won't work. That's it. It's a diode, and they only work in one direction. So here's the benefit. Now we've got the resistors in and we've cut the legs, fold it over, put it down on the table. What I like to do is just give it a little bit of a wobble, and then I'll go around and just make sure all of the longer legs are on the correct side and everything's looking right. Just straighten them up as you need to. Then take your soldering iron, tin your solder. What I tend to do is I will just do one side of the legs and work my way around, and the reason for this is, should you decide that you have made a mistake when you're reviewing it in a minute, or you need to just bend or move the LEDs, you're only having to move one leg. Again, you don't want to keep heat on here too long. You run the risk of damaging the components, and nobody wants that. So there we are, that's run round, and I just pick up, make sure that I've got a nice clean solder joint on every single leg, which is good. We'll then continue to go. So with that side soldered, I'm going to do exactly the same, just in reverse. Again, you can see these don't take too long to do. The tip I'm using on this soldering iron is probably a 3mm tip. It's a 7 in the Weller world, and I'm currently running at about 370 degrees, give or take. The solder I'm using is a melt at 270. I think that was the figure it was anyway. So with that done, I just pick up, check that I'm happy with all of the joints. All of them should be shiny, there should be no dull joints, there shouldn't be any big clusters. If you decide that you're not happy with something, you can just go round and you could retouch them. Again, after trimming, if you think that you've left a flap that was a bit big, you can just put the soldering iron back on and clean them up. Again, remembering that you need to have a little bit of solder on the tip, and that will then carry the heat round. If you don't have any solder pre-tinned on your soldering iron, you'll find that the heat doesn't go where you want it to. You won't be melting components. So often, if you want to remove a component, what you actually find you're doing is putting solder onto the component and then removing it, and you can use a little solder sucker. Essentially, if you make a mistake, you can push down, heat it back up, and it sucks out the solder. A particularly useful tool to have. So LEDs in place and resistors in place. So the next thing you do, just make sure that you're happy that all of the LEDs are straight and proper. There is a bit of wiggle room left in them. They don't sit completely flush, so just go around, tweak them. But that is your essentially finished board. The next thing you want to be doing to this board is adding some wire. So we just need enough wire to get us out of the headlight. You'll find that that is probably 200mm is probably sufficient. But what I do is I build it long and I put the crimps on afterwards. I advise you do the same as well. So we'll just remove this so we got a short length. Now if you're lucky, you might be able to push these straight through, but I struggle with this. So what I do is break back 10mm, and to make it easier for myself, I'll twist the black. You don't need to twist it, there's no reason for that, except it just makes it easier to get the strands in. On the back here, the cables go in from the rear, and there's a positive and negative. If you wanted to, you could solder them on the front, but they then wouldn't fit into the carrier. So we'll go with what works. And if you really want to mess around, there's nothing stopping you putting black in positive and red in negative. It just seems a bit bizarre to do that. So it will help if you have a third hand, a little claw or something just to hold everything. But what you can do is if you just position the wire correctly underneath it and let it all balance out, you can then get in with the soldering iron and just solder up those joints. There we go, that's the negative on, and then just gonna get my positive on. These have got nice big platforms on here, and the reason for that is I wanted to make sure that I could really load these up, give us as much mechanical strength as possible. So they're in, again, same process, take your snips, just snip them down so they're above the puddle, and we have a complete assembly there. So my next step is test it. So I've got a little bit extra length. That's all built up, and all we're going to do now is we're going to test and validate this before we put it into its housing. So snips, some wire, or strips of wire should I say. Again, twist it up, doesn't need to be twisted, it's just I find it easier to do this. Clear your desk, and then what I'll do is just get myself enough cable so I can put it into this power supply. All the units that I tend to build up, I always leave running for at least 24 hours and just make sure that everything's working right. I've had no failures, but I don't really want to be pushing my luck with that. So into the lab supply, let's switch that on. Right, so there's my LED. We've got no current and no voltage going to it at the moment. So what we do, give it some current, that allows me then to put some voltage on. And obviously these are designed to run at 12 volts, so there's your brightness at 5. Hang on, let's go down. That's going to be how bright it is when your battery's flat on your car. When you're running, you're typically going to be about 14, 14.5 up to 15. This is designed to take a fair amount, so I can see all of those LEDs are doing exactly what they want. If I shine on the wall, you'll see that the light beam is all collected together. It's not scattered as you see with a lot of the people who are putting LEDs into these housings. It's nice uniform, and it's daytime. I've got the lights on in here, and at night you could, I wouldn't advise that you do, but you could drive with these on. So this is your light pattern that comes from this daylight running light set. So the next part to do is essentially kill the power. You'll notice I'm not switching this lab supply off, and the reason for that is it doesn't. The switch failed a long time ago. So next step, our housing. We take the PCB and we align it into the housing. From there we just work around and we just clip this into place. Okay, so that's it done. LEDs in place. So now when it comes to bonding onto these, I normally put a small amount of polyurethane bonding agent in and bond them in. They do hold themselves, but I actually like to have the glue in there because once you took the headlights apart, you don't really want to be going back in and doing it again. So that's how I will finish that off. They'll get bonded in, and that is the complete assembly. It goes into the headlight, and until it's switched on, nobody knows that it's there. If I hook this back up to the power, there is no light bleeding. All of the light is localized around these areas that are opening. So for those that you may have seen out there, who put the LEDs in, you see there's a constant light bleed all the way around the cluster. So holding this here, let's give it some, hang on, let's give it some current first. There we go. It doesn't use a lot. There we go, that'll do. So there you go, you can see that all of the light is just around there, and all of the other areas you've got no light bleeding. It's a clean install, and when it's all switched off, you don't know it's there. So my final steps is on the back of this, before it gets bonded in, I will take some hot glue, and I put hot glue around where these wires go in, and the reason for that is I just need to take some of the strain off of that joint. I could have had the cables come straight off, and that's up to you if you want to solder them on differently, but I find a dab of hot glue around there works a treat. And you've always got the option, if you want to put a couple of dabs of polyurethane glue on the back to keep the PCB in there, you can, but they are clipped depending on how many times you take the board in and out, and I find that just a few dabs of glue will do it. So that is the cluster for the R53 headlights. Thank you for watching this video. I hope that you can subscribe, leave a comment. I will put the information in the links below, but as I've said in the video, if the links aren't there, assume that they're not available just yet. These units will be sold as a do-it-yourself kit, and they will be sold as a fully assembled unit, just like we're looking at here. And then this will be up to you to run your wire to your headlight and actually power these. I tend to power these units off of the ignition, but you could take it off the side lights and you don't need to worry about any CAN bus flicker on this. Down to the loading of the resistors and the LEDs that are used, this unit will not flicker with the hot and cold monitoring of the ECU. Thank you for watching. I hope you've enjoyed this video. subscribe if you can, comment if you want to. I do enjoy reading the comments. It's actually one of the enjoyments that I get from doing these videos, as well as helping people out and also showing products that I've done over the years. And I hope to see you again. Thank you very much.